All right, hello everyone. Thanks for coming to my very first talk, not just at Unite, but at any conference. I'm excited, a little bit nervous. Also, this presentation is fairly long. It was too long for me to memorize, and I've been on vacation for the last 10 days with my wife. So I'm going to have to read some of this from my slides. I apologize, but hopefully there'll be enough really good content here that'll make up for it. All right, so on to what is my talk called? Fixing Cars by Slapping Hog Butts and Milking Udders. Welcome to Hexas. That's me, Dale Newcomb. I'm the technical director at Owlchemy Labs. Raise your hand if you know Owlchemy Labs is and what games we make. Okay, only a couple. All right, now raise your hands if you know Job Simulator. Yeah, a lot more. We're not very good about marketing our name. It's everybody knows Job Simulator. Okay, let's move on. Here's what I'll be talking about today. I do both game design and development, so I'm going to be covering both sides of those things. I'll include as many tips as I can about how we make VR games in Unity. I'm going to be showing a lot of how we made things in our game, but I'm hoping you can see how it applies more generally. I wanted to show these examples in the context of a real shipping game, rather than just talking about them purely from an academic point of view. So hopefully that will be helpful for you. But before we start off on any of that, why should you care about my advice? First, I've been in VR for a really long time. Over 30 years ago, I was working on high-end VR equipment at the Naval Research Lab in Washington, D.C. I was using VR for location-based entertainment before the first VR hype crashed. We've had our second one recently, in the mid-90s when the funding went away. So while VR slept for a few decades, I was working in immersive simulators for military and law enforcement training. And then when the HTC Vive came out is when I knew that VR was finally back. Not the Oculus Rift Kickstarter, because in the early days I had worked with data gloves, and I knew from that some kind of hand presence was really essential for making good VR, unless you're just making like a driving, like a racing game or something like that. So it really wasn't until the Vive came out with the tracked motion controllers and room scale movement, that's when I knew. I was like, okay, VR is finally back. I'd been using proprietary C++ engines before that time, and so I taught myself Unity, and I started making games and demos as a solo indie developer. Even published one small game to Steam because I wanted to go through the process of doing absolutely everything needed to ship it, not just make a little demo. Highly recommend that. And then that led me eventually to Ubisoft in Düsseldorf, Germany, where I helped bring Assassin's Creed to VR. Did anyone here play Assassin's Creed Nexus? No, you really should. Then 3 years ago, I joined Owlchemy Labs. Owlchemy has made some absolutely amazing VR games and continues to focus on bringing new players into VR. The company's motto is VR for everyone, and we're really trying to broaden that market. In fact, when I was trying out the HTC Vive for the first time, when I knew VR was back in 2016, that was actually Job Simulator demo that I got to play. So it was very cool to finally be able to come and work for Owlchemy as the technical director. So now as tech director, I'm doing hands-on design and development work on our newest title, which is Dimensional Double Shift. So hopefully that's enough street cred. Let me give you some background on this game and what it's about. First third or so of my talk is going to be kind of going through understanding what this game is, so that then when I go through all of the details and the tips and everything later, you'll understand context. So Dimensional Double Shift is a cooperative free-to-play VR game. It's for 2 to 4 players. As most Owlchemy games, it's set in a very wacky universe. You and your coworkers do shifts in an interdimensional gas and grill. So you basically are fixing cars and making food. How many of you know about this game already? Okay, a few. All right, it's free to play. So if you've got a Quest or now an Android XR device, you can go play it for free. Here's a quick 30-second video showing an overview of the gameplay. right, so let's dig into some of the design pillars of dimensional double shift. At its foundation, double shift basically came out of wanting to modernize the core mechanics of our award-winning job simulator game and let you play it with friends. We've gotten over the years many people saying we love job simulator, but we really want to play with our friends. We decided that it really didn't make as much sense to put it in the job sim universe because there the bots are kind of like who you're mainly interacting with, whereas we want you to interact with your friends. And so the NPCs are more background. They're your customers in this case. But like job sim, we wanted it to have intuitive and natural interactions. We don't like things like pointing a ray cast at a 2D menu. When do you do that in real life? Never. We really try to make everything very diegetic and natural interactions. We wanted players to embrace the chaos. If our games are nothing else, they are extremely chaotic and let you do all sorts of crazy stuff and reward you for that exploration. Now that you also have other players with you, we wanted to add more embodiment to the character and their avatar through self-expression. You saw a little bit of it in the video of players being able to kind of interact with each other. I'll go into a little bit more soon, one of the big aspects of why that is. And then making communication and cooperation fundamental parts of the player experience. There's lots and lots of competitive shooters and all sorts of things like that out there. We really wanted to make a game that everybody could enjoy playing cooperatively together, whether it's friends, whether it's families. We've had people where there's a grandmother and playing with her young granddaughter. It's fantastic. All right, so when coming up with these interactions, we made one really important decision for this game. We made the conscious choice to go exclusively with hand tracking and not support controllers at all. Got us some negative reviews from hardcore VR gamers, but here's the thing. The current VR market is this tiny little dot right now, okay? There's not really that many headsets out there if you compare it to consoles and PCs and things like that. But the potential future market of VR is huge. It just has to get past several different barriers. One of them being, even though we've gotten a lot smaller, believe me, in the 90s, I actually had to have things holding up the weight of the headset because it was just like 30 pounds, 40, I don't know what that is in kilograms, sorry. But it was extremely heavy. And so even the ones now, they're still somewhat heavy. They need to get lighter. But there's other things that are blocking the adoption to the larger market. And one of those is motion sickness. A lot of players do get motion sick. So one of the things we did was make sure that there's no locomotion. I think locomotion is fine if your game absolutely requires it. I can't imagine us having made Assassin's Creed with no locomotion, right? You're parkouring across the city. You have to. But in a game like Job Simulator or Dimensional Double Shift, you don't need it. So recommend really evaluate whether you need locomotion or not. If you don't, try to design your game around not having it at all. Because even with teleport locomotion and things like that, players who are new to gaming in general or VR specifically, teleport doesn't really make sense. And when they come out of the teleport, they're a little bit disoriented. So even that, and then of course, smooth locomotion, 10-year-old boys, no problem. But that's that small little black dot right now, right? If we want to expand this to everyone, which our motto is VR for everyone, then we really need to do more. But back to the hand tracking. We wanted to make sure that you could play this from a good seated or standing position, but when you have a headset on, you can't even see the controllers. So if you are a gamer, actually, you know what? Let's do a look exercise. Everyone here knows what a mime is, right? The ones who get stuck in Unity cubes all the time? Yeah. Okay, so we're going to go through miming some of these actions together, which is actually something I like to do when I'm designing VR experiences, because since you're trying to build natural interactions, I just kind of imagine what the gameplay is going to be like, and I mime the actions. It really helps without even having to write a line of code. All right, so imagine I have just handed you this simple can of soda, okay? So I reach out and, okay, most of you just let that drop on the floor. That was rude. All right, how about we do it again? All right, I'm gonna give you this soda. Reach out and take it. Great, okay? Now, pass it from one hand to the other hand, okay? Raise it up and read the ingredients. Ooh, lots of caffeine in this one. I don't think I need that. Okay, now hold it in that one hand and open the top with the other. Okay? Salud. Easy, right? Okay, now crush it in your hands, throw it in the recycle bin. We don't want to put trash on the floor in here. Now, imagine that you are out here on the show floor. You have a company trying to sell a VR game, and there is a tech CEO. She's coming over to try out your game. But she's not a console gamer, so she doesn't really know the buttons on the controller well. She's a hardcore PC master race, FPS all the way. So she puts on the headset, and she kind of awkwardly takes the controllers you hand her. She's not even really sure how to hold them. You finally get her to hold them correctly. And she looks around. She's like, wow, this looks really cool. Oh, I see this 24/7 Up soda over there. How do I drink it? Now imagine having to explain to her what combination of buttons and grips and triggers and all of that stuff to go through that process of picking up the can, looking at the ingredients, opening the top, right? That's not intuitive. But how many instructions did I give you on how to hold the can, how to open the top? None. You just knew how to do it because we're all used to using our hands and interacting with things in real life, okay? So it does make it much, much easier, and you don't have to tutorialize things. All right. Let me see. I think I missed one thing here. Nope, got everything. In fact, the Apple Vision Pro, that was the reason that it launched with no controllers, was because Apple is looking at the long-term future and saying, it doesn't really make sense. People are in that larger circle aren't necessarily going to use the controllers. They need to be able to have very natural interface with their hands, and then we can add an optional controller later, which they've now, a year later, have supported. Okay. All right, now that that's out of the way, let's get back to our gameplay. But I want to make sure you realize, if you are going after the current VR market, those 10-year-old boys right now, okay, they're supposed to be 13, but they're all 10. You know it. If you go in those worlds, they're 10. You know, make it with fast locomotion. Like that's what they want. The gorilla tag type of movement, all that kind of stuff. They'll love it. If you are trying to go for the future of VR in the broader market, definitely don't be doing that, and really look at adding. You can add controller support, but what I would recommend is add hand tracking first, and then add controller support. We actually did add hand tracking support to Job Simulator and Vacation Simulator. And if you try those and then you try Dimensional Double Shift, you'll see a huge difference in the experience. And it's because those first games were made with controllers in mind. So all of your interactions are based on a grip, a trigger, and a couple buttons. So all of your hand interactions now have to simulate those things. But your hands are so much, more detailed and dexterous. And so if you start with controller support, you're limiting yourself. Instead, get the hand tracking support working well, and then add the controller support to try to make like a slightly less good version of the high detail fidelity you can get with the hand tracking. We will probably eventually add controller support to our game as an accessibility feature. Okay, so on to the game. Triaddle is our free-to-play dimension where most players start out. As we saw in the earlier clip, in each dimension, the gameplay is split across two main regions. In the diner, people make food for the customers. Sometimes it's very wacky food. And in the garage, the customers pull their cars in to be serviced by the players. I'm just going to use the garage today to show my examples, so I'm going to explain a little bit more about how that works. If you're looking at the top-down view of the garage here, each player is assigned to one of 4 distinctive roles. And remember, you can have 2 players, 3 players, or 4 players, where you can see these orange cones right now. Those are the 4 player positions. Each player has their own play space. Everything is right there within easy reach. All they have to do is turn around. Most of our players play seated. A nice rolly chair is the perfect thing. You just turn around and place. Each one has 2 unique appliances, one to the left, one to the right. And then in front of them, they have access to the car that has the different panels that they have to fix. Player to their left has a similar setup, but you'll notice that there's an overlapping space there. That is a corner of the car, and so that has a module that is meant for both players to interact together on. So it gives them a shared cooperation space. Sorry, get another drink. Okay, if you need to get items from across from the other players, then you'll have to either throw them or you can hand it to the player on their side and then they can hand it around. Either way works. Let's see. All right, so giving a bit more context when I said they have appliances, basically it's a unique tool that you have. Like one player might have a hose that sprays water and a fuel pump that has gasoline. Another player has like a vacuum cleaner and so in Triaddle, they're mostly fairly basic and understandable because this is the introduction to the game. We wanted to make sure that it was things that Earth people would recognize. Some of the later dimensions start getting a little crazy. So if we look at the appliances, those appliances are then used to fix the modules. The modules, you can think of it, the cars as like an inside-out escape room. So each one of these handles that you see, the player pulls that open and inside is the small puzzle that they have to solve. It might be something very simple, like the player at the top of the left image has a fuel pump right there. And if the player on the right-handed side of the car gets a module that has the fuel tank, then the first player has to just take the fuel tank, hand it over to the fuel pump, hand it over to the other player that has the tank, and they fill it with gas, right? Very simple way to solve the puzzle. So these all come in 3 different sizes. We've got small, medium, and then those large corner ones. Some of them, the players have to collaborate with each other. Some the player can solve by themselves. For example, if you were at the station that has the fuel pump and you happen to get the fuel tank, you just fill it with gas yourself. They get a lot crazier than just filling with gas, but that's a good place to start. We've got around 20 modules per dimension, and we kind of randomly spawn them in for each of the cars. You get 3 cars per shift. Okay, so now we're going to start getting into some details. So we look at a simple module here. This one is, some of the modules can be paired together. So this one basically unlocks another one. So this player has a handle, and it just says open and close, and they can pull it. And there's another player who's got a module that has the gas tank, but the gas tank has a lid that is locked closed. They can't open it. This person has to pull the handle that opens the gas tank for the other player to open it. So this is one of the ones where they're collaborating. So if we look at the prefab here, we've got the top level. The top level is where we have our single script that controls most of what's going on for this module. And it has references to other things within the hierarchy. So we've got the reference to the hinge and a reference to the open and close panel so that we can control it from that single script. We've got our visual meshes here. We've got our colliders here and our grabbable items here. Now, one thing you might not have done in Unity before is separate your colliders from your visual meshes in this way. I'm going to go into why we're going to do that. So first of all, though, when you're dealing with colliders, best to approximate things using a set of primitives for performance reasons. Sphere colliders fastest, followed by capsule, then box colliders. PhysX can calculate collisions with these types super quickly just using some simple math. If you need to do a cylinder, like we're showing in this bottom right one, then it's best to approximate it using a few boxes that are just rotated on the same axis, so you can kind of get an approximation. And that's because it isn't until you get about 100 primitive colliders that it makes sense to switch over to a convex hull, because the calculations are just so much more intense for trying to do collisions. Never use a non-convex mesh. Now, as far as why the colliders are separated into a different hierarchy, we do that for 2 reasons. One is because we like to be able to enable and disable sets of them and very easily do so by just turning on and off the game objects. Sometimes what we do is we'll have a complex set of colliders for when the module's being interacted with, and a much smaller, simple set of colliders when it's not. And we can basically do like an LOD for colliders by swapping those back and forth. Another reason for having them separated from the visual meshes is scale. You really want to have a 1-1-1 scale on all of your colliders. And if you add a default Unity cube and it adds that box collider on it, and now you go and take the cube and you scale it down to 0.1, 0.1, 0.1, now the game object that your collider is on does not have a 1-1-1 scale. As soon as you've done that, you've added costs to your calculations in physics. It's not always a lot, especially if you keep them, like if you were to do, but let's say you wanted a rectangular box. Now you have not 0.1, 0.1, 0.1, but 0.1, 0.3, 0.1. Now it's even worse performance. If you instead separate them, you can keep all of your game objects with colliders on them at 1-1-1 and get the maximum performance. So that's what we do, is we always keep them at 1-1-1. All right, when editing your primitive colliders, here's a little tip, because when you are able to scale game objects, you've got the nice little gizmo, right, to be able to scale it up and down. You don't have that if you have a 1-1-1 scale, and now you want to edit the collider. It doesn't have that nice thing, so you're sitting there typing, right? No. Instead, you click on the Edit Collider button to get to the editing gizmos. Now switch your scene camera to an isometric view using the buttons below the axes. Within this view, you can easily click on the various axes to switch the views, and you can then easily grab and resize the mesh. And so you'll see that very quickly, we're able to get a fully scaled mesh using no typing of numbers. Instead, you're still using a nice visual interface. And it keeps all of your scale at 1-1-1. If you try to do that when you're not in the isometric view, it is way harder. You'll get a much better fit. To help with setting up our colliders, we created a collider fill component, which I'm showing the code for here. It uses the on-draw gizmos to visualize how close we are to approximating the mesh. So what this helps us do is, as you can see on the left, it's almost all green, and it doesn't have too many areas where it's missing. So this is just rendering meshes on top of where the colliders are, so that we can see if like some part is sticking out too far, or if the box is too large over it. It makes it really, really easy to be able to spot check things without having to go through and look at each and every collider, because in order to do that, you'd have to go down through the list. Investing in a bit of tooling like this is really helpful. I highly recommend it. You end up loving using all of these things, so spend a little bit of time creating the tools. But as you can see in the code here, the component basically just goes through the colliders that are in the hierarchy, and for each one that's not a trigger, it draws a cube, a sphere, a mesh, or a capsule, depending on what the collider type is. A couple of notes if you decide to implement this yourself. Before this, for each loop here, you should save off the gizmos.color and the matrix values, and then restore them at the end of the loop. I didn't do that here just because it would have gone past, it would have made the text too tiny to see. Second, there is no gizmos.drawCapsule. So what we do is we just load a custom FBX mesh for a capsule, and then cache that, and then call draw mesh on it. All the other ones have built-in primitives, but not the capsule. Okay, on to our grab hints and grab techniques. So this is part of our hand system. To provide high-fidelity hand interactions, the grab system we implemented has three main parts. There's grab hints. Those are interaction points that provide what the grabbing affordances are on the object. We currently have about 16 different types, but really 7 or 8 of them are most commonly used. The rest are for very kind of fringe type of objects that just won't fit with those. In this example here, we have a cylinder grab hint that's on the shaft, and we also have a disc grab hint so that it can be grabbed by the top. And you can see in the bottom picture how that grab is happening. What you can't see here is that when you're grabbing the shaft there, it doesn't matter whether you're grabbing up high or grabbing down low. It'll support doing the whole thing. It doesn't just snap it into place. So your hands can actually decide to grab down at the bottom if you want to. Having your hand snap to a position that your real hand is not in with hand tracking, it kind of throws people out of the immersion. Okay, then grab techniques. Those are components that are on the player's hand, and they're monitoring the player's hand tracking pose, and they're detecting the intent. So if your hand is kind of in this shape, then you're probably trying to do like somewhat of a cylinder grab. So those are analyzing those poses and then looking for grab hints. So if I had this bottle and it's got a cylinder grab hint and my hand is doing this, those things can easily match up and say, okay, I'm trying to do that one. Whereas if my hand were up here on the top, I might get that disc grab hint and it would allow me to then grab it this way instead. Then the grab technique will get the settings from the grab hint that have just different things like the length and the radius of that cylinder, because we do try to form it to the hand so that what we don't want you to do is snap, but it does help to actually have the hand in the right distance away from the object, right? Because if your hand was grabbing here and floating, that looks weird. Or if your hand's penetrating into it, that looks weird. So instead, the grab hint itself that's on the object defines what that radius should be so that now when you've grabbed it, it tells the hand and the hand can kind of conform to that. So you'll see our players, if you're like just watching them in their room, they'll often grab things like this and then their hand will look correct. But the best way to play it is to actually mime the actions and actually grab like this. Because if you grab like this, it also changes what happens after that when you're trying to drop something or let go, which I'll go into a little bit later too. So then there's also the grabbable item components, and those basically give you information about how the interaction between the grab hint and the grab technique should be. So is this a grab hint that allows me to pick up the item? Or is this the lever where the lever is going to stay rooted in place, but it allows me to move it only along an axis? Or is it something that's going to allow me to turn a wheel or valve or something like that? So that's where that information is, and the three of those things work together. Okay, so this system lets us set up objects that can be manipulated in multiple ways. Here we've got our lever that can move by those two different grab techniques that we set up. We've also got a squishy ball that you can then squeeze. After we pick up this potato and we'll take a bite, then we can swap the grab hints, so now this accommodates the new shape. Each item can be grabbed in a variety of ways. It feels really natural with your hands. Okay. And that was a pinch grab hint at the end that you saw. All right, now that we've walked through some of these structures, let's move on to Hexas. This is where stuff gets weird. So as our first dimension DLC, Hexas is basically a cross between hell and Texas. Although if you've been to Texas in the summer, you might say it's hell already. I don't live there. But when working on a live services game, you need to be really careful not to get yourself stuck in a content generation treadmill where you're just constantly having to put out content at such a pace to keep your customers happy that you're just killing the team. And that is one of the things that often drives live services game teams into the ground. So you do have to, you do still have to keep things interesting, but you need to find a way to reuse content as much as possible without making players feel like the content was reused, because you don't want it to just feel like a reskin. So for VR, we've found some ways to do that. So for Hexas, one of the things we decided to do was to make the appliances fairly close to what they were in Triaddle, but with one key difference. We found that if you really just change the look, but everything else about it stays the same, it feels kind of like a reskin, even if you change it a lot. But if you change the affordances, basically the way you interact with the objects, that makes it feel different enough that it's okay that it has a similar look to the previous object. So on the left, let's see, never mind, wrong one. Okay, so for an example, in Triatle, you produce fire by going to the propane tank and turning a valve. And that basically makes fire come out of the torch that you've got. Okay? Now in Hexas, because stuff is very strange, you've got a fire elemental and you're feeding it coal. And now that powers the device. So you can see parts of it are the same and able to be reused, but the players don't feel like it's the same because even though now I've got this thing, I understand how to use this gun that shoots fire, but now instead of turning a valve, I'm getting to play with this cool demon thing that, when I move my hands around, his eyes track me and stuff like that, and he eats the coal. Like, it feels very different, but we're able to then reuse parts of it. Same is true of other appliances, including the vacuum and the electricity generator. Basically, what we tried to get a balance of is being able to reuse some level of game design, code, audio, or art. And by mixing and matching those things, we allowed each of our teams to have some level of reuse so that each team had like 80% new content, but 20% reuse. That saved them a lot of time. Okay, going into our first module case study, we're going to start simple and show why it's important to provide consistent and clear visual indicators of affordances when you're in VR. So in Triatle, we provided a socket wrench power tool for being able to turn screws, turn bolts. It basically looks like the green device you see there, but it was yellow. Literally the only difference. So that would feel like it's very much the same to players, right? Well, in Triatle, the module that you were dealing with was you had some things that had some bolts that were loose and you had to screw in the bolts. So you're fixing that by tightening those bolts. In this case, instead, we put the same type of bolt interface onto the puzzle, but the puzzle is now a rotating circle with different images on it that you have to align. So now you've already learned in Triatle, oh, this device can turn these screws, but now you're actually doing something different with it, and that felt different enough that we're able to reuse this pretty heavily. Our 3 Demon Maze modules are also examples of the same principle applied. We took the ideas of our different appliances, like you can generate fire, or you can generate air blowing out, or water. And instead of those doing what is kind of natural and expected, like with the one with the flame, you have a broken pipe, and you need to put the flame on it to weld it back together. Fairly explanatory. In Hexas, instead, you have a fire demon that you have to walk through a maze by applying heat to the different posts to attract it to that direction. And so now, even though you're still just messing with fire, you're doing something entirely different with it, and it made it feel good. Okay, taking this up. Hit list is our first example of watching how players interact with our game and then making adjustments based on what you find. Highly recommend doing this. As I stated earlier, we wanted players to cooperate. And the corner modules are the ones that are supposed to be solved by 2 players. What we found instead that many players were figuring out ways to complete those corner modules by themselves in Triatle. And so what would happen is one player would be doing something else or working with another player, and they'd turn around and this corner module had already been completed by this other player, and they're like, well, I didn't even get to do it, right? Which feels bad. So we were taking a look and seeing that, and so we started designing and making some different choices for how to design our modules to encourage the cooperative play and discourage being able to solve it yourself. So in Hitlist, what we did is we made this fairly tall and able to only really, each side can only be seen by one player. So we added what we're calling information passing as part of the puzzles. So one player sees the stuff on the right where they've got these stakes that are going into, excuse me, we got these stakes that are going into the things next to the pictures, and they don't know which ones to hit. But on the other side, that player has the hit list, which has 4 little Polaroid picture camera pictures of the players that they're supposed to take out. And so they have to then describe those players, which we've purposely made some of them kind of similar, so it had to made the descriptions a little tougher. And then they pass that information over and the first player hits it. This was now not easily solved by one player because they couldn't even see the other side. So it was just a good way of being able to like watch how your players are playing the game. If you don't have players yet, your play testers, like get people in who've never played it, watch how they're playing it, learn from that and make adjustments. For utter nonsense, we basically were attempting to encourage player cooperation again, but we approached this one in a different way. Instead of blocking one player seeing one thing and the other seeing the other, instead you have to milk these alien udders into a bucket until they're empty. And what we did is we made it so that when you do it with one hand, it goes really slow. 2 hands is a little bit faster, 3, and then 4, and it curved very quickly. So if you're doing it with all 4 hands like these players, you can finish the module fast. But if it's only one player doing it with 2, it's going to take a while. And this is really fun to do with hand tracking, and people really enjoyed it. So if they start to hear the sounds of somebody doing that on the other module without them, they'll drop what they're doing and try and go, wait for me, and they grab onto it and do it. So it was another way of, instead of putting a barrier to prevent somebody from doing an action, instead encouraging them to do the action. So players in this case can technically solve this by themselves. It just takes a long time, and the other players usually join in before they get a chance to. Also note that this is one of those things where this really sells people on the hand tracking. If you do this with a controller, it just doesn't feel the same. Doing it with the hand tracking, it feels really cool. And that goes on to one more module, which definitely is the case that is better with hand tracking, is the gas hog. So this is our final module case study that we'll look at. In Triattle, you might remember me talking about the fuel tank that you have to fill, and you had the lever that someone had to pull to open that up. So this is a case of we wanted to reuse game design, but not the art or the programming side. So in Hexas, what we did is you have the hog is over here on the right, the gas hog, and the gasoline in Hexas is not gasoline, it's barbecue sauce. And so you have to feed the barbecue sauce to the gas hog's head, but the head is closed and you can't get the mouth to open. Okay, similar to the lock on the gas cap in Triattle. Instead of just giving you a simple lever, the other side, there's a pig butt sticking out. The players have to slap the butt or pull the tail to make the pig squeal, and that will then make it open its mouth, and then they can put in the barbecue sauce. So where did this crazy idea come from? It actually came also from watching our players. When we watched our players playing the game, even when they weren't doing anything, right now they're just standing around the table where they're going to choose whether to play the diner or the garage and which dimension to go to. They do this all the time. They love slapping things with hand tracking. It just feels really good. Even though there's nothing there, we give those nice little affordance of a nice slap sound and the little poof particles, and it just feels like you're really slapping something. You can't do this type of thing very easily with controllers. In addition to slapping the tables, the countertops, the hoods of cars, so the little sphere with eyes up there, that's your AI manager named Alice. Players have slapped her over 22 million times so far. So it just made sense to give players more things to slap to try to solve the modules. Okay, so now I'm going to move on to the last section, which is additional challenges we faced. All right, hand tracking and player intent. So hand tracking is not perfect. Even with our complex grabbing system, trying to determine the player's intention with hand tracking can still sometimes be tricky. If you take the example of that squishy ball that we had, when is the player trying to unsqueeze it to squeeze it again, or when are they trying to unsqueeze it to drop it, or maybe even to throw it? There's not much difference between those two actions. So we had to really be careful about finding a way to define thresholds so that we could kind of tune this and also make it so that then normally when you drop something, we kind of wait a little bit before it can be grabbed again, because things, if you want to like drop something and grab something else really quickly, I want to pick this up, put it down, and then grab this. Things can end up grabbing the wrong thing and getting stuck if the tracking's not perfect. So we usually have a little kind of cool off of when you drop something. What we did is on certain objects like the squishy ball, we added a way to eliminate that cool down period so that now if the system does detect that I've let it go rather than re-squishing it, as soon as my hand starts to squish again, it re-grabs it and it doesn't just fall out of your hand. Another example, if you look in Unity's XR interaction toolkit, they have a keypad that you press with your fingers, right? It's got like a 0 through 9 buttons. And if you notice, excuse me, if you notice, they very smartly laid it flat on the table. Why is that? Because when your hand is this way, the cameras are what's doing hand tracking. It is now occluding, my hand is occluding my finger. I can't see it when I'm looking that way. And so the system, this is not just Unity, this is actually in the Meta system. Like if you're in the Meta home, as you go and put your finger like that and then try to kind of like hide it from your view, if you can see it, it actually starts to curve down because it thinks you're making a fist. So what happens is if you put that keypad up on like a door, like you're trying to enter the secret code to a room or something, you'll find that you end up pressing the buttons right below the row that you meant to push. And so in those types of cases, you have to really be careful. If you really want it to be vertical like that, you're going to have to take account for that and probably increase the where it detects you hitting, you're going to actually have to probably push it up a little bit or see if your finger is curled. And if it is, then say, okay, no, what would it be if it was straight, like doing a small raycast? Because there's nothing you can do about that. And so in the XRI toolkit, you'll see it's on the table because now when I'm doing this, I can see my finger perfectly. It's also a really good thing when you're designing the way your grab hints are to really think about whether or not any of your fingers are going to be occluded when you're doing these actions, because that's going to make tracking worse. Okay, multiplayer networking. In general, multiplayer is much harder than single player. I mean, this is pretty well known. But one of the tougher challenges we faced is balancing the need to be responsive to the local player's actions while also needing to get confirmation of that action from the authority client. This problem is not unique to VR. It's actually much more immersion breaking in VR, and handling it can be a little trickier. So if you're in a desktop game, a player may have a button to press or a lever to pull, and it can start animating right away, and that information gets sent out over the network. But in VR, you're actually pulling that in a very analog way. It's not, I pushed a button and now the lever went from there to there. I can pull it back, forward, I can do a little, you're doing that very analog. And in multiplayer, you now potentially have two people trying to grab the same things and all, and so it does make it trickier. You have to really be careful about how you deal with that. I mentioned earlier colliders, how we use primitive colliders for performance reasons. Doing that can sometimes, if you're really trying to be nice and tight with your colliders, you can end up with a lot. So yes, it's still better than using mesh colliders, but still be careful. We needed to change some of our game design in newer dimensions after Hexas, because in Hexas we had a lot of things that were very organic shapes, and those organic shapes were making it sometimes very difficult to put together primitive colliders in ways that match those shapes. So sometimes we'd end up with like 50 or 60 primitive colliders, which still better than the mesh collider. It's going to add up, especially in VR. In your mobile VR, you just don't have the performance there. So example here, this one has 42 colliders. Most of them are boxes and a couple of capsules. but there's also 18 trigger colliders that are needed for grab hints, snap points, collection zones, things we do. So I'd really like us to see it maybe get to about half of those numbers, so that we only have maybe 20 per object like this. So we're kind of keeping that in mind for future designs. Physics and joints. Physics can be really challenging in any 3D game, but one of the things, for example, is rigid bodies. Rigid bodies really should be on the top level game object. In fact, if you've used Unity physics with ECS, you'll see that even if you put a rigid body on some child component, the system actually automatically promotes it to a top level object during the baking process. Because that's how rigid bodies are actually supposed to work in physics as well. Unfortunately, that's not what a lot of people do. Most people end up putting a rigid body somewhere that's not on the top level. Because we spawn our modules in at runtime, we've already got a rigid body on the car, so to have a rigid body in the module, it's already not the top level. So one way you can solve this is you have joints. You can then have it be on the top level of this sub-object. It's got or this object. It's got a joint going to the other one instead of being a child of it. As you can see here, joints sometimes have problems. What this is supposed to be is this is supposed to be a lever that you can only pull forward and back along the two axes. And instead, you can see that when I use collision, I'm able to push it off axis. And unfortunately, like if you're in a flat screen game, you would probably never notice this kind of stuff. But when you're in VR, you're really up close to it. This object is right in front of your face. You're doing it with your hands. That looks janky, right? You ship a game with that just looks bad. And unfortunately, there's not a lot you can do about it if you want to use the physics joints directly. Side note, I was able to replicate this in Unreal 4 and 5, so it is also not unique to Unity. As a workaround, what we did is we created our own set of components that would do like the lever. We just do that with straight math instead of having it be physics. In VR, that's actually really helpful. There are certain objects in which you do need physics, right? Objects you're going to sit there and bounce around and stuff. But when you're doing something like a lever or the rotating thing, you can just compute that with math, and it saves you a lot of time and a lot of these type of headaches. Another way you can handle this too is, and we did it kind of in a test project, is you could have the joint here, but you don't have it on the visual object, and you just have the visual object try to follow the joint, but stay within the constraints. So in this case, I wouldn't be able to do that. It would look weird though, because my hand is now going to go through the visual object. So you're getting jank one way or another, unfortunately. Also, if you teleport objects that have physics, make sure to set them to kinematic first and then back to non-kinematic. We had a couple really funny demos that we did where we didn't do that. When you teleport it, basically the physics system treats that as an instantaneous force, which is how you make an explosion. And so objects will just go everywhere. It's also another reason why we try not to use physics as much in VR, because you end up having the player be able to apply forces to those physics objects that can be pretty intense, and you can end up with things going all over the place. If you play some of the very heavy physics-based games, you'll see that kind of stuff all over. Okay, and finally, hitching from spawning. We spawn the modules at runtime, as I mentioned. That can be kind of tough. Where they've got colliders, they've got physics, they've got anything heavy in the initialization scripts. All that stuff has to be done on the main thread currently in Unity. In desktop games, not as big of a deal. In VR, you get a little hitch like that, and now your players are getting sick. So huge deal. So basically what we do is anytime, like make sure to design in times in your game where you can fade to black. It doesn't have to be black, any solid color, as long as you don't have any more than one solid color. Fade out, fade back in. We do it when you're transitioning from that table they were slapping into the garage or into the diner. We fade to black, move the player, fade back in. During that time, we do preloading. So all 3 cars worth of modules get preloaded right then and there and spawned and then hidden behind other objects until that car is needed, and then those modules get moved in. That's where the teleporting comes in, which we forgot to turn to kinematic. This will help you a ton because you do not want those hitches. Okay, as a wrap up before we get to Q&A, here's a few things that I hope you take away from my talk if you're working in VR games. First, decide if you're really focused on that hardcore current VR market. If so, great, you know what to do. If you're wanting to go for the wider audience, make comfort your default setting. Let people pick things like locomotion or things like that from a menu. That's because if you by default have that and make it be, oh, I can switch to a comfort option, you're going to lose players immediately when they try it and you go, oh, I tried VR and it made me sick. I don't know how many times I've heard that. Oh, I tried VR and it made me sick. Well, yeah, because someone tried giving you a roller coaster game. Really sad. For live services games, find ways to reuse your work. If you make the right kind of tweaks, especially in the interactions, it really feels very different to players. Watch your play testers and players for how they're interacting with your game and learn from that and leverage what they do naturally. That slapping on the table was like, let's give them more opportunities to slap things, and they've loved it. Sorry, I'm now slapping things. Use primitive colliders and keep them in a separate hierarchy. Let you do that LOD type of thing, as well as keeping everything 1:1:1 scale for the maximum performance. And be very careful with your joints and rigid bodies. And then design in those fade to black transitions where you can do performance heavy work so your players don't get sick. Finally, since Owlchemy loves to reward players for creative exploration, this is what happens if you find some hot sauce to feed to the hog instead of barbecue sauce.
Ready? I love it.
All right, thank you.